Everyone knows, when you look at your standard bare wire electrical systems, you've got bare conductor, usually on cross arms or some type of standoff bracket. And between the phases and the neutral, the primary means of insulation is open air. And as we all know, that's kind of an inherently, unreliable system. It's prone to faults caused by, vegetation, wildlife, things like that. And it requires a lot of separation. You're going to need a lot of air between the phases to provide that insulation. If we look at the NESC code, 230D, it says that covered conductors shall be considered primarily bare conductors for mostly clearance requirements, except that the spacing between those conductors can be reduced. So essentially, the original concept of aerial spacer cable was we're going to replace a good percentage of that air used as insulation with a polyethylene, a covering on the conductor. So we can shrink the overall footprint of a spacer cable system quite significantly. And we'll talk about some of the specific dimensions here in a minute. We want it to withstand short-term phase-to-phase contact with vegetation, but it's got to be, it's primarily, momentary contact, incidental contact. Primarily what we want to do is limit the charging current on the surface of the conductor. So this isn't what you would consider insulated cable. Although the covering does have insulative properties, obviously you have nearly line voltage on the surface of cable, but what that covering really does is it limits the charging current on the surface. And our goal is always to get down to about 1/3 of a milliamp on the surface of the cable. That allows us to move it a lot closer together, and it minimizes any faults that can occur from momentary contact. Control of the surface charging current is really the key. The other thing is maintaining the covering integrity over its useful life. I think most of us in the industry kind of look at, electrical equipment has got like a 30 year or so useful life. I think we've said 30 to 40 years, but like I said, we've got some aerial cable that's been up in the air going on, 50, 60, close to 70 years. So this is your standard aerial spacer cable tangent construction. A couple things to point out. It's a messenger supported system. So the phase conductors just kind of sit slack in all of these spacers, these diamond shaped plastic spacers, which are made from the same polyethylene that we put on the covering of the conductor. You'll notice that they're kind of sitting slack in those spacers, and you're going to have one of those spacers about every 30 feet. The other thing you'll notice is we only use one side of the pole, so it's a pretty compact construction configuration, and we're only using one side of the pole. So you can take another one of these tangent brackets and put it on the back side of that pole, and you've doubled the capacity of your pole without having to go with a taller one. So it's a really efficient system from a space constraint perspective, but with that messenger supporting it, it's also a very strong, a very reliable system, especially from vegetation, trees and tree limbs falling on it. The messenger really protects those phase conductors from anything coming in contact with it. And the low leakage current on the surface of the cable minimizes or virtually eliminates any faults, whether it's a momentary or a sustained fault. We always kind of start with the conductor itself. For spacer cables, primarily all aluminum conductor, compact conductor, and where that comes into play is when you splice it. Obviously, you need to know it's 336 compact conductor, so you want to make sure that your connectors and your splices used for that are appropriately sized. And then we primarily make 3-layer cable these days. If you looked in our catalog, 10, 15 years ago, you'd see spacer cable, and then you'd see part numbers for tree-proof spacer cable. And that's the difference between 2-layer and 3-layer. And the third layer was always this strand shield, this initial thin polyethylene covering that goes right over goes over the strands of the conductor. And that just reduces the voltage stress, kind of balances it out throughout the peaks and the valleys of the stranded conductor. And then our standard product has got a layer of low density polyethylene, and then the outer jacket is what we call our high density polyethylene. And like I said, that's the same polyethylene material that we make all of our insulators out of and all of our spacers. So we know that all those materials are going to behave the same from an electrical perspective. That's one of the things that I'll refer to it a lot as is a spacer cable system. And we look at spacer cable as an engineered system. All these component parts work together from a mechanical and electrical perspective. And we've always maintained we want to manufacture the full system. That way we know that everything is going to work and we get the most reliability out of it. The inner conductor, we'll talk a little bit about spacer cable versus tree wire here in a minute. But the core conductor can be all aluminum conductor, ACSR, or even triple AC, aluminum alloy. And then the outer jacket, like I said, is high density polyethylene, comes in black and gray. Our system voltages start at 15, go all the way up to 138 kV. It gives you the reduced spacing, a lower partial discharge, higher BIL rating. You'll get about 200 kV just by the covering that's on the conductor itself, and that's our thinnest conductor at 15 kV. One thing you'll notice is it's not, I'll refer to it a lot as covering. It does have insulative properties, but personally, I don't like to refer to it as insulation, especially when we start talking with linemen. If you start talking removing the insulation, the thickness of the insulation, I don't want to give them the impression that this is fully insulated cable. This is not. This is considered a dielectric covering. It's not insulated, it's not shielded. So from an operational perspective, it's still treated just the same way as bare. Now there's some advantages, some benefits about moving it close together, but there's still a minimum clearance that we need to maintain between phases. Incidental contact, momentary contact, it'll be fine. You still won't cause a fault. How long can a tree sit on it before it faults? It really kind of depends. We've heard stories of trees sitting in it for 6 months, up to over a year before we even see a fault on it. So it's pretty rigid stuff, high BIL, high impulse strength, and UV resistant.